Hello and welcome to my channel. This is Yugal, and a brief introduction about myself. I have scored 99 plus percentile in JEE Mains and a decent rank in JEE Advanced examination. So here we are discussing about the most important chapter of the topic of JEE and Neet, that is salt hydrolysis, and it's quite important. So here in this salt hydrolysis, we categorized it into majorly three parts. The very first is hydrolysis of salts of strong acid and weak base. Second one is hydrolysis of salts of strong base and weak acid. The third one is hydrolysis of salts of weak acid and weak base. Before moving ahead, we should write a note here that cations and anions from strong acid and strong base doesn't get hydrolyzed and they remain same in water. Like we talk about NaCl, then the Na plus and Cl minus, they remains in that form only in water. They doesn't further react with the water. So here we are talking about the hydrolysis of salt of strong acid and weak base, which we precisely write as strong acid and weak base in this form. So before moving this, we will write some of the examples of salts of a strong acid and weak base, like the very first NH4Cl, the other one is NH4 whole twice SO4 ZnCl2, etc. So weak base get hydrolyzed. That's why it is called cationic hydrolysis. Weak base having a cationic portion. So here this is a base and this is the acid part. So this gonna get to hydrolyze. As this comes from the strong acid, this does not react with the water further. But yeah, this comes from a weak base. This will react from the water, and we also call this as a cationic hydrolysis. So cationic hydrolysis. In this cationic hydrolysis, we will take an example to understand this. Like one of this example is NH4Cl. You will find that the dissociation of water is like H plus plus OH minus, which will give you Kw is equals to H plus into OH minus. The constant for this is this. We named this equation 1. The other thing you will like, the base NH4OH minus will dissociate as NH4 plus plus OH minus. The constant for equilibrium constant for this comes to be NH4 plus into OH minus upon NH4OH. This is equation number 2. So here we are doing a cationic hydrolysis, that is NH4 plus H2O. This gonna gives us NH4OH plus H plus. The H plus coming here is gonna increase our pH. Hence from here we will find that it's a part of a strong acid. So acid dominates here. So pH will be less than 7. In the second part, you will find like either base dominates, strong base. Here pH will be greater than 7. This is just for information purpose. So we can write this equilibrium constant, this hydrolysis constant, as KH here. So with KH is equals to, you will write it as NH4OH into H plus upon, NH4 plus. So now for getting equation number 3, we will subtract equation number 2 from equation number 1 to get equation number 3. Moving ahead of this, by subtracting equation 1 from 2, you will get equation number 3. And you know that constants and equilibrium constants get divided when we subtract this equation. So kh is equals to kw upon kb. How you will get to know about this? Like kw is equals to h plus into oh minus upon kb is equals to, you will find that kb is equals to nh4 plus into oh minus, and that will go up nh4oh. Fine, oh minus cancel out. This is nothing but this is kh. So kh is equals to kw by kb. This is important thing, you should remember. This is very important. The first thing you should remember this is this, nothing other or just proof. You should remember this. This is very important. Now moving ahead of this, you will write this equation as nh4oh. This nh4oh here, this is a base. We are doing hydrolysis of this cation, that is nh4 plus. We're gonna write as nh4 plus plus h2o. This is gonna give us nh4oh, that base which we have taken here, plus h plus. So if this have a concentration of C, this at time t is equals to 0, then at some time at equilibrium time t is equals to t is gonna have C1 minus alpha. This is an axis. This is an axis. So gives you C alpha into C alpha. We are going to find a pH from this. So this is kh. So we are going to write kh as C alpha into C alpha upon C1 minus alpha, as this is axis. This is written as 1. So we know kh is this. C to C cancel out. You find C alpha square upon 1 minus alpha. As here by assumption, initial concentration, as here by assumption that that dissociation is very negligible, as it's a weak base. It's a weak base, so dissociation is negligible. So we can neglect this as a 0. You will find here the C alpha square. So kh is equals to kw upon kb is equals to C alpha square. You will find here kw upon kb into C is equals to alpha square. So alpha is equals to under root of kw upon kb into C. Here we have alpha is equals to under root of kw upon kb into C. So now for the concentration of H plus, you will get is C alpha. So multiplying here C, we will get as kb. Okay, so what does the pH refers? It's equals to minus of log of concentration of H plus. So pH is equals to minus of log of this under root of kw into C upon kb. So this is also very important formula. This formula you should remember. The H plus concentration is this. So pH is this. You're gonna find pH is equals to minus half, log of kw plus log of C minus log of kb. From this you will get the formula as pH is equals to 7 minus half pkb minus half of log of C. You will not get to know that pH is equals to 7 minus half of pkb plus log of C. This is very important formula. You must remember this formula. This is must formula. You should remember this. Thank you.